Alrighty, chemistry students, welcome back. Today we're going to be looking at significant figures. Significant figures are incredibly important in chemistry, and you will need to know this concept moving forward for the rest of the year. So please make sure you pay close attention and watch this video a couple times if you are confused. Our learning target is today is that the learner will correctly identify the number of significant figures in a number. Make sure you've done warm-up number 8 if you haven't already. Otherwise, let's get started. You will need your note packet today because we will be taking some notes. Apologies if you can hear the lawnmower in the background. So, there's 3 big rules about significant figures, and these are in your note packet. So, the first being that non-zero digits are always significant. The second, that any zero between 2 significant digits are significant. And the final being that a final zero or trailing zeros in the decimal portion are the only ones that are specific. So, I'm going to go through some examples of what these means because that is foreign language to you. But you will need to know these rules. So, here's some examples. So, looking at rule number 1, rule number 1 states that any non-zero number is significant. Any non-zero number is significant. So let's look at this first number, 492. Is the number 4 a 0? No. Is the number 9 a 0? No. Is the number 2 a 0? No. So any non-zero number is significant. So 4, 9, and 2 are all significant, leaving us with 3 sig figs. Because the 4, the 9, and the 2 are all significant. Here we have the number 2, I don't even know, let me see, 2,938,434,482. Are there any zeros in that number? No. So how many sig figs do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sig figs. This next number has a decimal. Generally, you need to pay attention to decimals when zeros are involved. But in our number 23.4939, there are no zeros involved, so you don't need to pay attention to the decimal. We can just count our total number of sig figs like we did above. So we have 1, 2, 3, 4, 5, 6 sig figs and 23.4939. And then lastly, the number 0.34892, I want you to take a moment and identify how many sig figs are in that number if we're following the rule that any non-zero number is significant. Good. We would have 5 significant digits in that number. Let's continue on to some examples from Rule 2. Maybe. Rule 2. There we go. Remember, Rule 2 states that two zeros have special rules depending on where it is and if there's a decimal point. So, zeros between 2 numbers are always significant is our first rule. So zeros are special, but if they're between 2 numbers, they're significant. So, if you have a whole number and a zero in between, they make a sandwich, and that internal part is important. We need that internal part. So since this 0 is between 2 whole numbers, it counts. It is significant, leaving us with 3 significant figures in this number. In this absolutely gigantic number, do you think these zeros would count? Yes or no? Yes, they would, because we have another 1 and a 2 on the outsides of them. So we have to count every single one of these zeros because they're in a sandwich. It's a very big sandwich, but it still has 2 buns on the side. So we will count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 significant figures in that number. Please identify for me how many sig figs you think are in this number. Notice we have 2 separate zeros, and they both have whole numbers on both sides. So we are again going to count all of them. So we have 1, 2, 3, 4, 5, 6, 7 sig figs. Ignore that bell. Let's move on to Rule 3. So Rule 3 is a tough one. It involves leading and trailing zeros. So leading zeros are not significant. Trailing zeros are significant if they have a decimal, and if they don't have a decimal, they're not, which gets confusing. So let's start with leading zeros. Remember, Rule 2b states that leading zeros are not significant. So notice here, oh no, sorry about that. Notice here that we have the number 0.00012. We have 4 zeros here. Are these zeros in a sandwich? No, because there's nothing in front of them. There's no whole number there. It's just a bunch of zeros. So we only count these 2 numbers. So there is 2 significant figures in this number because these zeros aren't in a sandwich. Let's look at this number. We have the number 0.002310. So first let's identify our zeros. We have 3 zeros in this number. Is this 0 in a sandwich? Yes, so we count him. This 0 is also in a sandwich, so we're going to count that 0 as well. Is this 0 in a sandwich? No, it's not. So we need to look at our trailing zero rule. So if you go back to our rules, it tells Rule 2c tells us that trailing zeros may or may not be significant. Now remember, a trailing zero is something that comes at the end of a number. Trailing means the end. So if a trailing zero has a decimal in front of it, they is significant. So we are going to count that 0. So we would have 1, 2, 3, 4, 5, 6, 7 sig figs in this number. This one is very similar to the first one we did. How many significant figures are in that number? There are 4 significant figures in this number because we have to count these 2 zeros because they're in a sandwich. This 0 is not in a sandwich, so we do not count him. Our last example, 124,000, has 3 zeros in it. First question, are those zeros in a sandwich? No, they're not, so we don't count them that way. However, they are trailing. But if there's no decimal in front of them, they're not significant. So there is only 3 sig figs in this number. Things get tricky when decimals are involved. So let's pretend there's a decimal here. A decimal in this situation counts as our top bun or our bottom bun. So if there's a decimal here, then those zeros are significant. This single decimal changes our sig figs from only 3 to placing a decimal and having 6 sig figs. You have some more examples to practice with on your own. I'm going to go through those shortly in a moment. Alrighty, I'm going to make myself a little bigger here. So, in your packet, you have these practice problems at the bottom for identifying sig figs. I want you to take a moment, about 5 minutes, pause the video here and practice those identifying the number of sig figs, and then I'm going to check those answers with you on the video. So go ahead and just pause your video for a moment while you answer those questions with the number of sig figs and why, and then I'll go over those with you in this video. Alrighty, let's go through these ones together. So our first number that we have is 45.8736. Are any of those zeros? No, so all of them are significant, so we would have a total of 6 sig figs in that answer. This one, we do have a decimal, but these are leading zeros, and there's no whole number in front of them, so those zeros are not significant. So we're going to count 1, 2, 3 sig figs. In this next number, again, we have these leading zeros. So we are not counting those zeros because they don't have any whole number in front of them. We also have these two number zeros. These two, I don't know what's going on anymore. These two zeros that are trailing behind. And because they are trailing a decimal, they are significant because there's a whole number involved. So this number here has 5 significant figures. Notice here that we have a decimal at the end. That decimal is going to count as our bottom bun. So we again have 5 significant figures. This number only has 2 whole numbers followed by 3 zeros with no decimal. They're trailing zeros with no decimal. So we only have 2 sig figs. And we are going to ignore this bottom one for now. So we are going to come back to that at the end of the lesson once we learn scientific notation. So what I would like you to do now is if you did not do well identifying those 5 numbers of significant figures, there is a supplemental video created by someone else that teaches sig figs again. I would propose that you watch that on your own before moving on to the homework. You do have homework to complete today. It is on various pages of your packets that I provided you. And your homework looks a little different if you're in honors chemistry or general chemistry. So make sure you check Canvas for what homework you need to complete. And then there will be another video on multiplication and division using sig figs shortly. As usual, email me if you have any questions. Thank you.